Let's explore JavaScript callbacks. Callbacks are a fundamental concept in JavaScript, especially when dealing with asynchronous operations. A callback is essentially a function that's passed as an argument to another function. This allows the code to be executed after a specific task completes. They are the foundation of asynchronous programming in JavaScript, enabling non-blocking operations. Consider this example. We have a function called fetchData which takes a callback as an argument. Inside fetchData, we simulate an API call using setTimeout. After 1 second, the callback function is executed, passing the string data received as an argument. Callbacks are used in various common patterns throughout JavaScript. They are often used in event handling where callbacks respond to user interactions like clicks, key presses, and form submissions. Callbacks are also used for data processing, for example, array methods like map, filter, and reduce utilize callbacks. Timers such as setTimeout and setInterval are other use cases for callbacks. Lastly, they are essential in AJAX calls for handling asynchronous HTTP requests. Let's examine event handling. We select a button element from the document. We then add an event listener. The second argument to the event listener is a callback function which is executed whenever the button is clicked. When we map over an array of numbers, each number is multiplied by 2 using the callback function. In the case of a timer, the callback function will be executed after a delay of 1 second. Callback Hell, also known as the Pyramid of Doom, occurs when multiple asynchronous operations need to be chained together. This leads to deeply nested callbacks, making the code hard to read, difficult to debug, and complex to maintain. Consider a typical scenario where we first need to get user data, then orders based on user ID, then order details, and finally process the order. The problem lies in the nested structure. Each level of callback is dependent on the previous one, creating a difficult-to-follow flow. It becomes hard to trace errors and modify this type of code. This is a problem that needs to be solved. To solve Callback Hell, we use modular functions and named callbacks. The first step is to break down the complex operations into smaller named functions, which have a single responsibility. This allows for a clear flow with a sequence of operations, with each step handling only one specific task. By breaking up the logic, we are able to use a centralized error management system, making error handling much simpler. In this example, we have functions that handle errors, process order details, fetch user orders, and get order details. These functions now use the then and catch methods. The main execution flow starts with getting user data, then it fetches user orders, and we handle any errors that may come up. This pattern keeps code clean and maintainable. When working with callbacks, it's important to implement proper error handling. The first practice is to use the error-first callback pattern, where the first parameter is always reserved for errors. This allows you to handle both success and error cases separately. It is best to always check for errors in your callbacks. Use custom error objects for specific scenarios. And make sure you propagate errors up, which means passing errors to upper-level error handlers. Let's explore error handling. When using Notage's file system read file function, the callback gets 2 arguments. The first is an error and the second one is the data. If the error is present, the callback should handle it. We can define a custom database error, which can be used to throw or pass on to error handlers. When we implement error handling, we can also check for the type of error and then call the appropriate error handling function. Let's explore asynchronous operations. Asynchronous operations are how JavaScript handles tasks that take some time to complete, such as fetching data or setting timers, without blocking the main thread. The event loop is the heart of this system. The call stack is where the JavaScript code executes. When an asynchronous operation like a timer or an AJAX call is encountered, it's moved to the web APIs. The web APIs handle the task without blocking JavaScript's main thread. Once the task is finished, the callback function associated with it is moved into the callback queue. Then the event loop checks the call stack. If the call stack is empty, it moves a callback from the queue to the call stack to be executed. Let's explore an example. First, we start by logging start. A set timeout goes to web APIs. We also have a fetch call which goes to the web APIs. Another set timeout goes to the web APIs. And finally, the last statement is to log end. The output order will be start, end, timer 2 finished, data, and then timer 1 finished. Let's explore advanced asynchronous patterns. When we have multiple tasks that don't depend on each other, we can use parallel execution, which means that we execute them simultaneously to improve performance. It is best to add timeout logic to prevent infinite waits. It is also good to aggregate results from multiple async operations in a structured way, and to optimize parallel operations while managing system resources. Let's examine parallel execution. Here we have a function which takes a list of tasks and a callback. We iterate through each task and execute it. The results are collected in a results array, and the final callback is called when all the tasks have finished. The function then uses the function and passes 3 fetch calls to it. Once done, it will log all the results. Let's discuss best practices for writing better callback code. First, keep your functions simple. Each function should have only one responsibility. Make sure you handle both success and error cases properly. When using callbacks becomes too complex, consider using modern alternatives like promises or async await. Use early returns to avoid deep nesting. For example, here we define a function that accepts a user ID and a callback. We start by validating the user ID. If it's invalid, the function returns early, passing on the error. This avoids deep nesting. If the user ID is valid, then we call a function to fetch data from the database. If there is an error during the fetch, we return early, else we process the data in small steps and call the callback function at the end. It is important to note that we can also use async await, which makes the code easier to read and follow. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.